All right, hi everyone. Let's continue. And you can, I hope this is useful. I think even just having it play sometime in the background can be useful, like a kind of a virtual companion. So we sit alone and work alone. All right, so now you're not alone. You've got me nattering away in the background while you try to focus. Okay, so we're just going to round up this section. Few useful facts about probabilities. Okay, so we normally express it as a decimal because a decimal is very easy to see which number is larger. It can also be expressed as percentages or as fractions. It represents a proportion. In other words, it's a number between 0 and 1. It's a proportion because 1 is all 100%. Like if you flip a head, there's a 50% chance of flipping a head. There's a 50% chance of flipping a tail. The chance of flipping either a head or a tail when you toss a coin is 100%. Okay? So it's a proportion. So it can never be greater than 1 or less than 0. The probability of an event, okay, what was the other term? A favored event is also called a p-value, p-value, p-value. So you will sometimes see the p-value of x is 0.02 directly from the textbook, meaning the probability of x is 2%, or 2 out of 100, or 1 out of 50. Okay. So, that also conversely means, this is an interesting thing that's probably got some complex math behind it, but there's a 0.02 probability that that particular result, the p-value of x, can occur by chance. Which is an odd statement. I think that, okay, there's obviously some math that proves that. There must be. Okay, when decimal notation is used to describe probabilities, it's between 0 and 1. The closer it is to 1, the greater the likelihood of success, and the closer it is to 0, the lower the chance of success. 1 being the equivalent of 100%, and 0 being the equivalent of 0%. Okay, so then there's greater than or equal symbols, which are in the book. I haven't delineated that for us. Okay. Two events are independent if the occurrence of one has no effect on the probability of the other occurring. Okay, so each coin toss is independent of any previous coin toss. Two events are mutually exclusive, such as a coin toss. If it's a head, it can't be a tail. It can't be both at the same time. Okay, now let's go on to the additive rule. Now, the way to understand the additive rule and the multiplicative rule is through visuals again. So here we have the set of A and the set of B. The additive rule is to say that an event can fall anywhere between these two circles. Okay, it could be here, it could be here, it could be here, anywhere in there. So if you're adding the probability of A and the probability of B, then obviously it's the sum of those two circles. So it's added, all right? So it's like, what is the probability of a card being a heart and a card being an ace? Meaning that any ace is fine and any heart is fine. So you would add the two together. Okay. Now, can you see this part here? You wouldn't want to add that part twice. So we'll get into that later on. Now, the multiplicative rule is what are the odds of something being in this little overlap area, okay? So you can't add them, that's not possible, but say the chances of it being in A are 50%, okay? And the chances of it being in B are 50%, 1 over 2, 1 over 2. The chances of it being in this little section here, A and B, is then going to be a quarter. And you can kind of see that if you look at that space is approximately a quarter of the two spaces joined up. Okay, here it looks like a third, but if you do the math, it's going to be a half times a half. So 1 times 1 on top and 2 times 2 on the bottom is a quarter. All right. Okay, and there is a symbol for showing those two concepts. And you know, I've forgotten it. I've drawn it so many times. Let's look it up. It's A intersect B, and okay, so we're going to go statistics, symbols, A intersect B, and A union B. I'm remembering the words. Okay, there we go. A union B. So that is when it's either A or B. So that would be additive, okay? That upside down, that U without a line, a symmetrical U. Intersect is when it's A and B, and that will be multiplied, okay? And I don't see these symbols in the book, but you will sometimes see them, so it's nice to know them. A union B is A or B, okay? A and B at the same time. Intersection is the upside down one, okay? So there we've taken it just a bit deeper than the textbook. Union, intersect, and union. Hang on, my brain. What did I just say to you? Union is or, intersect is and. Yes. So union, when you put the two into one set, the union, that's additive rule. When they intersect, that's the multiplicative rule. Okay? And ironically, this is the and this is the or. Okay. All right. Then we're going to go on to conditional probabilities next. Now, conditional probabilities are when you say, okay, this A, what is the probability of B given A, which is symmetrical with the probability of A given B. So we're going to go into that. Now, you'll see a really frightening looking formula on page 37. I'm going to show you how it fits together in a probability tree, which is very easy to draw and which makes it obvious and intuitive to work out the probability for simple conditional formatting and for Bayes' rule. And then we'll have a quick glance at the math after that. Okay.